everyone, Victoria here with Lowell Observatory, and I'm bringing you guys another fun science challenge, this time to deal with electricity. We'll be making a small little battery out of coins. The key here is you need two different types of coins, so two different types of metal, and you need paper towels soaked with salt, vinegar, and water in between. This is because all batteries work by creating a chemical reaction, but it's a special kind of chemical reaction where electrons are kicked off and then they move. So here the electrons are going to move from one coin to the other, from one different kind of metal to another different kind of metal. That's called an electrochemical reaction, and that's how all the batteries we use work, but it's also pretty easy to make on your own. So without further ado, we'll get started and making our own batteries. To make our coin battery, these are the materials we'll need. You won't need a multimeter, but I'll be using one for this demonstration. You'll also need a paper towel, some scissors, make sure to use them carefully, nickels, pennies, a small strip of aluminum, and a light bulb. With this one, you can see it has two tiny little wires on the ends. Those are very important, and that's where you'll actually connect the light bulb. You will also need a salt and vinegar solution. To make one, have a parent help you heat up some water. Heat it up until it's just about boiling, and then very carefully add salt in and mix until the salt doesn't dissolve anymore. This makes a saturated saline solution. Then add a splash of vinegar or apple cider vinegar or any other kind of vinegar you have on hand. And mix that all together, and that is our solution. Now, what you'll do is we'll take the paper towel and soak it in the vinegar solution. Now, when it comes out, it's going to be dripping wet, so instead just squeeze it, wring it out, try not to get it everywhere, and then it'll still have the solution in it, but it won't be dripping wet anymore. So, set this aside. Now, we'll need to make our battery. So, to make our battery, start off with your aluminum strip and set it down. Next, take a nickel and place it on top. The aluminum helps us measure or connect the battery. Next, you're going to take your paper towel and cut a very tiny square. You want it to be small enough so that it covers, big enough so that it covers the whole surface of both coins, but just small enough so that the edges don't really droop over and touch each other. Next, you're going to take a penny and lay it right on top. Then take another nickel and put it on top of your penny. And this layering process is one cell of your battery. So again, we're going to take that nickel is the first step, and then you take a slice of this paper towel, lay the paper towel down so the coins don't touch, and put the penny on top. Do this for as many coins as you have. I only have 4 nickels and 4 pennies, so that is how many cells I'll be making. But mine won't actually light up my light bulb, as you can see. So your challenge is to then make a battery that will light up a light bulb. So, one last paper towel square. And there we go. Let's see if the light bulb works, just in case it does. So here we touch one end of the wire onto the top of the penny and touch the foil onto the top part. And no light. So you know that you need at least 5 cells of a battery to make the light move or light up. Now let's see how much of a potential is across here. Don't worry too much about what exactly potential is, but just know that here we're dealing with electricity. And electricity is really just tiny little electrons, the tiniest part of an atom, moving. And here, just like all other batteries, we have what's called an electrochemical reaction. So we have the two different metals, the pennies and the nickels. Those are our electrodes. And then in between there, we have ions. And so in the salt, we have extra electrons. And those extra electrons can move. Both of these, or actually all three kinds of metal we have here, the aluminum, the copper, and the nickels. I forget what nickels are made of. I don't think it's nickel. But anyways, all three different kinds of metal are good conductors. So we can wiggle around the electrons inside of them and make electricity go through it. So let's see how much we have here. This happens because there's a chemical reaction going on, shutting off those electrons. So we've got about 0.2, 0.3 volts. That's pretty good. So you can see that there is a potential across here, just not quite enough. So my challenge for you is to figure out how many cells of a battery, and if you can, how much of a potential you need to actually light up this light bulb. You know, it's got to be more than about 0.3 volts. So share your answers, share your batteries, even if they don't work with us, and make sure to have fun while you do it and stay safe as well. This isn't a high enough current where it wouldn't cause much damage, but still, please be careful. Try not to touch anything that has electricity going through it. And if you do, try and wear some kind of protective glove.